All right, you are welcome again. Let's take a look at this problem, okay? Under exact equation on differential equation. Now, this question says we should show that this equation is exact and we are to solve, okay? Now we have y plus 1 over x in bracket dx plus x dy is equal to 0. Okay, so this is an equation. We are asked to show that this equation is exact and then we are to solve. Okay, now by definition, what do we mean by an exact equation? We say that a differential equation of this form m dx plus n dy is equal to 0 is said to be exact if the partial derivative of this m with respect to y is equal to the partial derivative of n with respect to x. Hello. The part that is having the x, call it a letter m. The part that is having the y, call it a letter n. Differentiate m partially with respect to y. Differentiate n partially with respect to x. These two partial derivatives should give you the same value. So we say that the equation that this m and x is coming from is an exact equation. Let's test it. Now, the part that is having the x is y plus 1 over x. And then the part that is having the y is n. We say that m is equal to y plus 1 over x and n is equal to x, right? Differentiating m partially with respect to y is going to give us 1. Differentiating n partially with respect to x is going to give us 1. You will see that partial m all over partial y is equal to partial n all over partial x. Thus, we say that the equation is exact. Now, going further to solve this, we see that the solution that we are looking for is the integral of m dx plus integral of n dy equal to 0. Hello. Now let's integrate our m with respect to x, integrate our n with respect to y. Now doing so, we're going to have the integral of y plus 1 over x dx plus integral of x dy equal to 0. When we integrate the first part with respect to x, so when we integrate y with respect to x, it's going to give us xy. When we integrate 1 over x with respect to x, it's going to give us ln of x, then plus c, right? Then the other part, we have the integral of x with respect to y. It's going to give us xy. Then we have plus c. So look at this carefully. These two integrals that we have, there is a term that is common, xy. So we're going to pick one of them, right? So picking one of them, we're going to see that we have xy plus ln of x plus c is equal to 0. So therefore, this is the solution to the differential equation y plus 1 over x in bracket dx plus x dy equal to 0. Thank you very much for watching. Let's take more example. Stay blessed.